All right, in the second of our asynchronous lectures on climate change, I want to again return to the issue of how we measure change. And remember that I said change is extent, magnitude, and rate. And so what we're really asking is, okay, if climate is changing, how is it doing so in those three respects? And in part, we have to look at climate over time. So again, if we return to that then, what we're going to ask about is how temperature, precipitation, and extreme weather events have changed. Again, extent, magnitude, and rate. So let's begin with, we need a context. That is, what are we going to compare it to? And this is a data set that's been widely used, but I think it is, and there are obviously some challenging issues with it, but in general, I want you to look at those components of it. First of all, we're going to take the very simple one, the one that we have the best data on, and that's temperature. And what we can say, again, if you will, this is today, and then we're going to go back 2,000 years. And what we can say fairly, with a fair level of confidence, is that global average temperatures were relatively stable for an extended period of time, and then we had what we call the Little Ice Age. And again, it was a period of time when the world did cool a bit during the period roughly from about 1400 to the late 1600s, early 1700s, depending on where you are in the world. But then this is what I want you to focus on again, and that is both rate and magnitude. You'll notice that very quickly, since 1850s, global temperatures have climbed dramatically. In other words, significantly more than any decrease in temperature or moderate increase through here. And so again, rate is the steepness of it, very steep and significantly high. Now the question then becomes extent. Well, where did this happen? And so again, what we want to do is we want to look at this parameter and we want to say, okay, what is the change in global temperature? Now, what I'm going to do next, there's a video that we're going to watch briefly, and this is the change in temperatures globally. Again, I want to define a term here. Anomaly means the departure from an average value. So, global temperature anomalies from 1880 to 2017, that is, for a 30-year average, how much has the temperature changed? And I'm going to let this loop, and I'm going to kind of point out a few things. So, notice what we're seeing here again. This is the years, and the temperature zeros are essentially white, no change. Blue means it's getting colder than average. Yellow to red to orange means it's getting warmer. Now you'll notice that now we're entering in, and I'm going to pause it here. You'll notice that we're entering into the 1940s, and we're beginning to see this warming cycle here throughout Europe, and especially in the extreme northern hemisphere. And that's one of the things that is important to understand. Temperature change especially affects the higher latitudes earlier and more significantly. Now again, we're up into the 1959. You'll notice that everything's kind of in an average. And then we see this beginning to happen. And again, starting in the 1970s, this wide swath that continues to be present. Some have argued that we've reached that tipping point at this point. Now you'll notice essentially globally it is present, in other words, anomalies above average for the time period, and now you begin to see this very distinct high temperature anomaly in the northern latitudes. And it gets worse and worse. All right, so what we can say there is extent now is global to a large degree, certainly focused or emphasized more in the northern hemisphere. The rate is extremely fast, and the magnitude is pretty high. All right, so next, won't loop that again. Let's move on to our next slide. We can look at this a couple of different ways. That is what history says. In other words, we have data for that. The models now suggest the following. So if we look at this, this is mid-20th century and late 21st century. And what we're seeing here are two scenarios. One, if we act to radically reduce greenhouse gases, and the other essentially as we do exactly what we're doing right now. And what we see, this has changed, happens to be in degrees Fahrenheit. And what we see is that we're going to have a significant, you'll notice here are the lines, we would see an annual temperature change on the magnitude of 10 to 12 degrees Fahrenheit. Now that's annual, and that means that our summers are going to get significantly warmer, and as are our winters. Now again, if we act, it looks, again, if you see here, we're already at the lowest scenario, still 4 to 6 degrees of temperature change across most of the United States. That's one of the other things we need to recognize very early on, is that we've crossed a point where we're not going to see change. It's simply a question now of what the magnitude of that change will be. If we look at the overall trend, again, since the Industrial Revolution, the overall trend in temperature, this is global and temperature changes, both land and ocean, and what we see is the anomaly, again, 0 degrees is our relative value. And if you were to draw a smooth line through this, what we'd see is that, again, degrees Fahrenheit, the anomalies are now approaching roughly almost 2 degrees Fahrenheit by 2021. That's what we see. Now, precipitation is likely going to do the same thing. The evidence suggests that's the case. When we talk about global precipitation, we have to understand a little bit about what we really mean. And of course, when we looked at the climagraphs, we were looking at totals of precipitation per month. But precipitation we have to be a little bit more nuanced with. And that is that it's not just how much precipitation we get, or how little, but it's the timing of it relative to growing seasons and how much we get in in a sense, one lump. And that's what we're going to look at in terms of extreme weather. Now, one way that I do want to look at this very quickly is to say change in precipitation, liquid water per year, and this is what we can expect by the end of this century. And what I want to point out is that some areas are going to get significantly wetter. The Indonesian archipelago here into Java and Sumatra, significantly wetter. Moderately wetter as well in terms of Alaska. But within the United States, and I'm going to focus here for a moment, you'll notice that the lower Midwest is going to get significantly drier, as is the Southwest. And what is particularly disconcerting about these two areas for the United States is these are very important in terms of our food production. The other point that I want to make is this area here in Brazil, significant impacts in terms of relation to the dry forest adjacent to the equatorial rainforest, as well as West Africa, again, large populations here that are going to experience significantly drier climates, as well as India, large populations here are also going to experience significant changes in precipitation. Now, it's, again, as I said, it's not just how much precipitation, but the timing of it. And for the United States, this is particularly problematic. You'll notice the spring, which is, again, the rain that is necessary for planting and the early growth of crops. And what we're seeing here in terms of our models moving forward is that this part of the Southwest is going to become very, very dry. Now, I want to point out, again, I'm going to get out of this for a minute. We're going to look at a different scenario. This is actually the U.S. drought monitoring system. And unfortunately, right now in the United States, we are in a severe drought in that area that I just pointed out. This map shows magnitude of drought, and you'll notice again right here, the red is extreme drought, severe and moderate, and you'll notice that much of California, and in fact much of the Southwest, is in a very significant drought state. And that's been the case for a period of time, and in fact it's a significant change. So again, magnitudes of change and extent. Let's go back to our presentation. I want to point out a few other things here. When we look globally, what we're looking at here is the amount of area that is going to be affected by extreme levels of drought. And what you'll notice is that we can see that here again in the United States, southern United States, southwest, we're going to see some significant increases. Again, Pennsylvania will likely in fact see more rain. One of the concerns in Europe is that this is also where we get extreme events such as flooding. India particularly concerned about droughts, as is Australia. So again, precipitation. Now, the last piece of this in terms of the impacts of climate change are the extreme weather events. And what we have here, and this is one way of looking at the extreme events, and in an introductory class, I don't want to get too much into the details of some of these extreme events, but note what we have across the top: droughts, flooding, freezing events that occur outside of the norm, tropical cyclonic events, and severe storms. And what you'll notice, again, from 1980 to 2020, the number and the cost, this here is not the count, this is the cost in billions of dollars. And what you'll notice is that the severe storm, cyclone events are producing literally hundreds of billions of dollars in cost to the United States. The extreme events, now including ones such as droughts, are driving the cost of our society up dramatically. So we have to think about that. We have changes in temperature and changes in precipitation. But as we move into the last part of these lectures, what I want you to think about is, what do we do? And one really practical way of asking the question, how much can we afford to do, is to flip it around and ask, what is the cost of not doing these things? And again, this is a study that came out from Forbes. This is by no means a news source that it promotes this. It is a fairly unbiased assessment of the costs of our current activities. And so it is worth understanding that the cost of climate change is becoming fairly catastrophic, and this is just in the United States. Okay, that's the end of Lecture 2. Please make sure you look at the supplemental materials and then the video for Lecture 3.